By part A, by sketching a suitable pair of graphs, show that the equation cosecant x equals 1 plus e to the negative 1 over 2x has exactly two roots in the interval from 0 to pi. We can let y1 to be cosecant x and y2 to be 1 plus e to the negative 1 over 2x. We sketch the graph y1 and y2 in the interval from 0 to pi. Don't bother with the rest. You just need that interval only. So we have the interval from 0 to pi. And let's say we have pi over 2 and pi on the x-axis. Consider the first case, y1 equals cosecant x. y1 equals cosecant x. Cosecant is the reciprocal of sine x. So on the interval from 0 to pi, let's say the graph of sine x, sine 0 is 0, sine pi over 2 is 1, sine pi is 0. So on the interval from 0 to pi, the graph of sine x is concave down. The reciprocal of 1 is 1, the reciprocal of 0 is positive infinity, is not defined. So for this case, if you look at the graph of cosecant on the interval from 0 to pi, you just have a graph that is concave up. Sine graph concaves down. The cosecant function will have a graph that is concave up. So at the point y equals 1, this is the minimum value, and we do have a vertical asymptote here from at pi. So the graph of cosecant x actually concaves up. That will give you y1 equals cosecant x. y2 is 1 plus e to the negative 1/2 x. When you have e to the negative 1/2 x plus 1, this graph has a horizontal asymptote y equals 1. So you have y equals 1, and e to the negative 1/2 x is a graph that is decreasing all the time, but it will never touch the horizontal asymptote y equals 1. When x is 0, we have y of 0 equals 1 plus e to the 0. That has a value of 2. So the y-intercept is at 2 for the graph y sub 2. And then we also have the case when x is pi, we can compute y of pi here. This is 1 plus e to the negative pi over 2, which has a value of 1.21. So you have a graph that decreases all the way to y equals 1. And we can see that there are 2 points of intersection. So there are 2 roots for the equation. Cosecant x equals 1 plus e to the negative x over 2 on the interval from 0 to pi. So that is the first root, and that is the second root. Part B, we are given an iterative formula where x sub 1 equals 2. It converges to one of these roots. you need to use this formula to determine one of these roots correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So x sub 1 is 2. Then using the iterative formula, x sub 2 is pi minus inverse sine of 1 over e to the negative 1 over 2. Replace x sub n by 2 plus 1. We should get a value of 2.3217 to 4 decimal places. Find x sub 3 now. We are not done, so we have pi minus inverse sine of the reciprocal of e to the negative 1/2. This x is now 2.3217 plus 1. And we have a value of 2.2760. Both of them do not converge to 2 decimal places. So we continue with x sub 4. That gives us pi minus inverse sine of 1 over e to the negative 1/2. This x sub n is 2.2760 now. And that is 2.2824. The 2 decimal places that is still incorrect. X sub 5, here pi minus inverse sine. Now we replace the x value with 2.2824. That gives us a value of 2.2815. To 2 decimal places, they are the same. Therefore, we say that the root is 2.28.